Imagine you're standing outside right now, sun on your face, warm, normal, and then nothing. The sun is just gone, not exploding, not fading, simply erased from existence in an instant. What happens next? Not in a year, not in a week, in the next 8 minutes, and then every hour after that, your world, your planet, everything you've ever known begins to unravel in ways that are far stranger than you'd expect. Here's the first strange thing. You wouldn't even know the sun was gone. Not immediately. Light travels fast, about 300,000 kilometers per second, but the sun is roughly 150 million kilometers away. That means the light leaving the sun right now takes about 8 minutes to reach your eyes. So if the sun vanished this very second, you'd have no idea. You'd still feel warm, still see blue sky, still squint if you looked up. For 8 minutes, everything looks completely normal. The last light the sun ever sent you is still racing toward Earth, and you're living inside that lie. Then at minute 8, the sky goes dark. Not slowly, not like a sunset. Instantly, like someone cut the power to the entire solar system. And that's when the real question kicks in. How long do we have? Now here's something most people don't think about. Gravity, like light, also travels at the speed of light. So at the exact same moment the sky goes dark, minute 8, Earth also stops feeling the sun's gravitational pull, not 8 hours later. Not gradually. Right then, for billions of years, Earth has been locked in an orbit around the sun. A perfect, stable curve. Remove that anchor, and Earth doesn't just slow down, it shoots off in a straight line, like a ball released from a slingshot, continuing on whatever direction it was heading at that moment. Depending on where Earth is in its orbit when this happens, it would head off into interstellar space, away from every other planet, away from everything. At our orbital speed, roughly 30 kilometers per second, we'd be moving, but the nearest star is over 4 light-years away. At that speed, it would take tens of thousands of years to reach it. We're not heading anywhere useful. We're just drifting. Let's talk about temperature, because this is where it gets brutal. Right now, Earth's surface temperature is maintained almost entirely by the sun. Without it, the cooling begins within hours. The first week, temperatures drop dramatically. Surface areas lose heat fast. Within a week, average temperatures globally might fall to around 0 degrees Celsius, or lower. Within a year, average surface temperatures could drop to around -70 or 80 degrees Celsius. The atmosphere itself starts to behave differently. Wind patterns collapse, precipitation cycles break, snow falls and nothing melts it. But here's something genuinely surprising. The oceans don't freeze immediately. Water holds heat incredibly well. The top layer of the ocean might take years, possibly decades, to freeze completely. And that means life near deep ocean vents, far below the frozen surface, could potentially survive for an extraordinarily long time. Ecosystems that already run on geothermal heat rather than sunlight. The surface becomes uninhabitable. But deep below the ice, something might still be alive. Now think about the food chain. Specifically, think about photosynthesis. Every plant on Earth runs on sunlight. Without it, photosynthesis stops. Not slowly degrades, stops. Immediately. Within days, plants begin to die. Some can store energy and last weeks or months. But the process has already ended. No new energy is being captured. The base of nearly every food chain on land is gone. Animals that eat plants starve. Animals that eat those animals starve. The collapse cascades upward through the food web with terrifying speed. What about oxygen? Earth's atmosphere has enough oxygen in it to last humans a long, long time, thousands of years. Running out of air is not the immediate threat. The immediate threat is food and heat. Humans, however, are resourceful. Geothermal energy, heat from the Earth's own core, doesn't care about the sun. Nuclear power doesn't care about the sun. Artificial lighting in underground grow facilities could sustain crops. Theoretically, a small population could survive, not easily, not comfortably, but the physics allows it. So, could humanity endure this? That's the question we're building toward. Let's zoom out. Because it isn't just Earth that loses its anchor. Every planet in the solar system, Mercury, Venus, Mars, Jupiter, Saturn, all of them, simultaneously loses the gravitational force holding it in orbit. Every moon, every asteroid in the belt, every comet, they all scatter. Some head inward toward where the sun was. Some head outward toward interstellar space. The tidy, structured system that has existed for 4.5 billion years dissolves in a single moment. Jupiter, the largest planet, had its own moons held by its own enormous gravity. Those remain in orbit around Jupiter for now. But Jupiter itself drifts. The solar system, as a concept, ceases to exist. Within millions of years, these objects scatter across space so thoroughly that nothing would ever indicate they were once part of the same family. There's something almost philosophical about this scenario. We talk about the sun as if it's a backdrop to our lives. A constant. A given. We build calendars around it, religions around it, entire civilizations around it. But it is a star, a single, middle-aged, completely unremarkable star, one of roughly 200 billion in our galaxy alone. It doesn't owe us anything. It wasn't designed with us in mind. It simply happened. A cloud of gas and dust collapsed under gravity about 4.5 billion years ago, and the heat and light it produces happens to fall on a small rock at just the right distance to allow liquid water. That's it. That's the whole story of life on Earth. A coincidence of distance. If the sun disappeared, the universe would not pause. Every other star out there would keep burning. Every other planet would keep orbiting its own sun. Life, if it exists elsewhere, would carry on completely unaware. We are not central to any of this. We are just lucky to be here, for now. So, how long would humanity survive if the sun disappeared right now? Here is the honest answer. Most life on the surface would begin dying within weeks. Temperatures become survivable only in specially heated shelters within months. The majority of large animal life on land collapses within a year or two. The surface becomes a frozen wasteland within a decade. But a small group of humans, with nuclear energy, geothermal heat, and the knowledge of how to grow food artificially, could potentially survive indefinitely underground. Decades, centuries, perhaps much longer. Earth itself would survive as a rock. Its core would remain hot for billions of years. The planet doesn't die when the star dies. Only the thin, fragile film of life on the surface does. And somewhere under the ice, in thermal vents at the ocean floor, microbial life might not even notice the sun is gone. Because for those organisms, it never mattered in the first place. The strangest answer to this question is not how quickly we would die. It is how small a role the sun actually plays for life that evolved without it. Life is more stubborn than we think. The sun disappearing is the kind of thought experiment that sounds like science fiction, until you run the physics and realize every single step of it is real. The 8-minute delay, the orbital slingshot, the slow freeze. None of this is guesswork. It is just the universe behaving exactly the way it always does, without us in mind. If you want more of this, real science told the way it should be, subscribe. There's a whole universe of these questions, and we're just getting started. Next time, what actually happens inside a black hole? Not the Hollywood version, the real version. And it is stranger than anything you've imagined.